So good afternoon guys. So as we know that we are going to topic that is current electricity, and in previous topic we were discussing about waves, right? So in the totally 5 questions was there, we have discussed 3 questions, right? So the remaining 2 questions we'll discuss, and we'll start with the current electricity topic of class 12th. Okay, yes. Let's first discuss the last 2 questions of waves. Okay, so whoever missed the topic in the previous class, no, you can go through that video and you can watch that. Okay, yeah. Yes. Okay, so the first question we have completed, that is explain the formation of stationary wave in stretched string and hence deduce the law of transverse wave in stretched string. Okay, yes, we have completed this question, and the second question is, yeah, explain the formation of stationary wave in air column enclosed in open pipe. Okay, is the second question, and we have discussed the third question also, which is a closed pipe. Okay, so now we will go into the fourth question. Yeah, so this is the fourth question. So what is Doppler effect? Explain an expression for the apparent frequency of sound heard when the observer is in the motion with respect to source at rest. Okay, so first we'll understand what is the question has been given, right? So we'll divide the question into subtopics. So first I need to explain what is the meaning of Doppler effect or Doppler shift, right? So obtain an expression, I need to write an expression, okay, for an apparent frequency of sound when the observer is in motion, okay, and source is at rest. So with respect to it to take, okay, with respect to I need to take, okay. So this is the question. So first what we need to write? Doppler effect. So what is the meaning of Doppler effect? The difference between apparent frequency heard by the observer and actual frequency produced by the source. Okay, so apparent frequency heard by the observer and actual frequency produced by the source is called Doppler effect, right? So I need to write the expression now. So when the source is at rest and observer is in motion, towards the source I need to take, right now. So source is rest, observer is in motion. So this is going with velocity v naught. Okay, so the distance between them is lambda. Okay, so let the velocity of the observer towards the source is at rest, that is v naught. Velocity of the sound is v. Okay, so we have written 2 v's, no, v and v naught. So this is velocity of the observer towards the source, and v is nothing but velocity of the sound. So you can take a note of this Doppler effect first. Fatima. No, this class is purely based on English. And I too don't know Hindi, that's why. Done. Okay. So v naught is the velocity of the observer towards the source, which is at rest, and v is the velocity of the sound, right? So since both velocities are in opposite direction, no. So first of all we need to understand the relative velocities. Okay, let me explain the thing. When object A is going with VA velocity, object B is going with VB velocity. Okay, so the formula is, whenever we are writing with respect to velocity of A with respect to B is nothing but, this is the formula, velocity of A minus velocity of B. Okay, when I talk about velocity of B with respect to A is nothing but, what is first one? B is there, so VB minus VA. Okay, so this is a formula thing, but whenever we are talking about a velocity, I need to talk about the direction also. So simple, this is my positive, negative, positive and negative. Now if you see the arrow mark, so which arrow mark it indicates? Positive, no? So both are positive, right? Now we have talked about the diagram. This is my velocity of the, velocity of the sound V, and this is my velocity of the observer, right? No? So when I talk about these two things, this arrow mark indicate negative, this arrow mark positive. So velocities are both in opposite direction. So relative velocity of sound with respect to observer. So sound with respect to observer, no? So let me take this as S. So VSO will be equals to VS minus VO. Why minus? It is negative, no? Negative direction. So what we can write? V plus V naught. Right, no? So that's the answer we got here, no? So have you understood the topic, that is relative velocity, how we need to assume and how we need to write it? Right. So since the source is not moving, there is no change in wavelength. So wavelength will not be changed because the source is not moving here, no? This is at rest. Now, so no change in wavelength of the wave reaching the observer. So the wavelength of sound will be, lambda will be equals to V by N. Okay, this is my first equation. Now apparent frequency I need to find. So N dash will be equals to relative velocity of sound with respect to observer. What is the relative velocity? V plus V naught. Right now? So wavelength of sound is lambda equals to V by N. So now what we can write here? Relative velocity of sound with respect to observer, wavelength of sound. What is wavelength of sound? V by N. So N into V plus V naught by V. Why N into, like V by N, no? This is V plus V naught by lambda. What is lambda? V by N. So V plus V naught by V into N. So this is my apparent frequency. Okay. So what is N here? It is frequency, right? Okay. So since V plus V naught is greater than V, the apparent frequency N dash is more than the real frequency of the sound. Done? So V plus V naught, no. So if I consider this is 5, obviously this one some number will assume. Okay, 5 plus some number will be, obviously it is more than 5 only, no. So V plus V naught will be more than V. So obviously N dash will be more than N. Right. Now when the source is at rest, observer is in motion away from the source. Away from the source. So initial case what we have assumed? So observer is coming towards the source. Now observer is going away from the source. So away from the source in the sense, both are in positive direction. Right now? So V minus V naught I should take. Right now? So let the velocity of the observer away from the source is V naught. Velocity of the sound is V. Since both this velocity are in same direction, relative velocity of sound with respect to observer is V minus V naught. Here it is V plus V naught. Here it is V minus V naught. Now, since the source is not moving, there is no change in wavelength. So lambda will be equals to V by N. Right. So now apparent frequency N dash will be equals to relative velocity of sound with respect to observer by wavelength of sound. Correct, no? So what is relative velocity? V minus V naught by V by N. Now what we can write? N into V minus V naught by V. So obviously V minus V naught value is less than V. Right now. So we can say that since V minus V naught is less than V, the apparent frequency N dash is less than the real frequency. Got it? So the final result is, for a moving observer, the stationary sources N dash will be equals to N into V plus or minus V naught by V. One we got V plus V naught, one we got V minus V naught, right? No? So for positive sign, when observer moves towards the source, for negative sign, when the observer move away from the source. Got it? Yeah, you can take a note of this. If you are having any doubt, you can ask. Okay. Yeah, from here, no? Yeah. You have taken the diagram, right? Okay. Done? So which one? Okay. Done. Second one. Okay. So complete it first, we can go for the next one. Okay. You have taken down this one. Okay. 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 So the next question is, so what is Doppler effect? So we have seen what is the meaning of Doppler effect. Now obtain an expression for the apparent frequency of the sound here when the source is in motion. Previous question what? Source is at rest. With respect to observer is at rest. In previous question observer was in motion. Here source in motion, observer rest. In previous question observer was in motion, source was at rest. Okay. So what we should do now? One condition is velocity towards the observer. Okay. Second condition is velocity away from the observer. So first condition towards the observer will take. Okay. When the source move towards the observer, observer at rest. Okay. So since the source is in motion, there appears a change in wavelength because like it is keeps on reducing, no? So wavelength will be reduced. So let's, here the diagram you provides goes S to O, like the diagram is there, no? From S to O it is going. Source moving towards the observer, yes. So let's see, velocity of a source towards the observer is at rest is Vs. So velocity of the sound is V. So since both these velocity are in same direction, so relative velocity will be V minus Vs. Okay. So now the apparent wavelength will be lambda dash will be equals to relative velocity by frequency of the sound. Okay. So what is the relative velocity? V minus Vs. So by N. Now apparent frequency will be, so N dash will be equals to V by lambda dash. So in previous case why we have taken only lambda? Because lambda was not changing. In this case lambda is changing. Okay, lambda is changing. So whatever things is changing, no, we will take as a apparent. Okay. Why lambda is changing? This is source is moving, no. So when source is moving, lambda keeps on reducing between the observer and the source. Okay. So V minus Vs by N. Okay. So now apparent frequency means N dash will be equals to velocity of a sound by apparent wavelength. Okay. In previous case what we have taken? Apparent velocity by wavelength we have taken. Here it is velocity of sound by apparent wavelength. Okay. So velocity of sound is V, sound, by apparent wavelength is what? V minus Vs by N. So N into V by V minus Vs, right. In the previous case what it is? V plus or minus Vs by V into N, right. No, here it is N into V by V minus Vs. It is apparent frequency, right. So since V minus Vs is less than V, the apparent frequency N dash is greater than the real frequency, right. No, now when the source move away from the body in the sense V positive direction, Vs negative direction, so both are in opposite direction, right. So one is positive, one is in negative. So what will be the relative velocity? It is V plus Vs, right. No, so the relative velocity will be V plus Vs. See, so diagram like S moving away from the O. So let the velocity of a source away from the observer at rest is Vs and velocity of a sound is V. So since both velocities are in opposite direction, so relative velocity will be V minus Vs. So the apparent wavelength of a sound with respect to observer is lambda dash will be equals to relative velocity. What is relative velocity? V plus Vs, right now, divided by frequency. Now apparent n dash, that is apparent frequency, will be equals to V by lambda dash. What is lambda dash? It is V plus Vs by n. So when we substitute the value, it is Nv by V plus Vs. Okay. So since V plus Vs is greater, so we can say that the apparent frequency n dash is less than the real frequency, right now? Okay. So what is the conclusion here? N dash will be equals to Nv by V plus or minus Vs. Okay. This is the conclusion of this fifth question. So you can take a note of this. Take the question and you can take the answers. Okay. So one is Doppler shift, right now. So this is Doppler effect. So when we talk about Doppler effect, apparent change in frequency of a sound observed due to relative motion between the observer and source of sound, right now. Apparent change in frequency of sound observed due to relative motion between the observer and the source. Okay, but this one is the difference between apparent frequency heard by the observer and the actual frequency. Okay, here the actual frequency takes place. Yes. So this is relative motion between the observer and the source sound. Okay, both are different, like it's Doppler effect and Doppler shift. Okay. Done. So whatever the question we are discussing today, there will be exam of this, I mean on this question tomorrow. Okay. Completed up to this. Okay. Make it first, we will go for the next question. So the next question will be from the current electricity chapter. Okay, wavelength has been, I mean wave has been completed. Done. So the final conclusion will be n into V by V plus or minus Vs. Okay. Completed, guys. Take it now. Fast. Done. So it's the last line. Complete it fast. Done. Okay. So now we will go for the current electricity chapter. Okay. Yeah. So first question which we are going to see is, state Kirchhoff law for electrical network. Using this law, deduce the condition for balancing Wheatstone bridge. So first part of the question I need to explain what is the Kirchhoff law, right? And second part of the question, by using the Kirchhoff law, I need to explain the condition for the balancing Wheatstone bridge. Okay. So first, Kirchhoff laws. So first law, like Kirchhoff current law will say, okay, sum of current flowing into a junction is equals to current sum of the current coming out of the junction. Okay, so the algebraic sum of all current meeting at a point like junction point will be 0. So if we take this is the junction, okay. So what are the currents are coming in? I1, I2, I3. So what are the currents are going out? I5 and I4 and I5. So can we say like I1 plus I2 plus I3 will be equals to I4 plus I5 will be equal, no? Sum of current coming in will be sum of current going out, will be equals to sum of current going out. So or else the other thing what we can say, I1 plus I2 plus I3 minus I4 minus I5 should be equals to 0. So the sum of all current meeting at any junction is 0, or else we can say sum of current which is coming out of like going into the junction will be equal to coming out of the junction. Okay. Now this is based on the law of conservation of charges. Okay. Now the Kirchhoff voltage law. First law is current law, second one is voltage law. In any closed circuit, the algebraic sum of potential difference is equals to 0. Any closed circuit only. Okay. So this law is based on law of conservation of energy. So this one is conservation of charge and this is conservation of energy. Right. So sign conventions we need to know. Why we need to know about sign conventions? When we are traveling in a circuit, okay, whether we are going from positive to negative or negative to positive, okay, or we are going in the direction of current or we are going in opposite direction of current, okay. So when we move across the resistor in the sense I am crossing the resistor, okay, in the direction of current, okay, let me take that. Suppose this is my resistor. So this is the current flowing direction and I am going in this direction, which means the potential drop across the resistor is taken as minus IR. So this is minus IR we should take, this is R and this is I. Now similarly, when current is going in this direction, I am coming opposite direction. So what I should take? It is IR plus IR, no? So when we move across the resistor in opposite direction of current, this is direction of current and this is opposite direction of current. So direction of current is minus IR, opposite is plus IR. If we move from negative to positive terminal of cell, so negative to positive in the sense this is negative and this is positive, no? Negative to positive terminal, EMF is taken as positive, okay, like V will be taken as positive. When we are going in this direction, positive to negative, it is minus V. So it from positive to negative terminal, EMF is negative, okay. So 3 points we need to clear about that, okay. When we are moving across the resistor, no, in the direction of current, it is minus IR. In the opposite direction of current, it is plus IR. Negative to positive terminal, positive V. Positive to negative terminal, negative V. So we are going in negative but we are coming out as a positive. We are going in as a positive but coming out as a negative. Understood the sign conventions? Fine. Okay. So from the figure, like figure is like down, like the diagram is down, okay. Like we'll take the diagram here. Suppose there is a 3 resistor, okay, and a cell is there. So current will be going in this direction. So current is going in this direction in the sense like I am going in positive, so negative coming out as positive, negative, positive. So this one should be taken as positive, no? Yes, no, positive only. This is I. This is my current direction. So I will be traveling like this, no? Traveling to negative, coming out as positive. So E will be positive. This is my R1, R2, R3. I am going in the direction of current. So minus R1, minus R2, minus R3. So E minus R1, so IR1 minus IR2 minus IR3 will be equals to 0. Okay, we know that V is equals to IR, no? E is nothing but EMF, V is nothing but EMF only, no? Right. So minus IR1 minus IR2 minus IR3 will be equals to 0. So where I can write as E is equals to IR1 plus IR2 plus IR3. So we can take the I commonly outside, no? So when we take the I commonly outside, what will happen? E will be equals to I into R1 plus R2 plus R3, right, no? So if I need to find the current, I will be equals to E by R1 plus R2 plus R3. Okay, so this is how we will find the circuit equations, right? So when we go for the Wheatstone bridge, so Wheatstone bridge consists of 4 resistors, so named as R1, R2, R3 and R4, connected as shown in the given figure. Like this we will connect them. Okay, R1, R2, R3, R4. Okay, so the current will be I1, I2, this is I3 and I4, and this is Ig is nothing but the galvanometer current. Okay, and there will be no current through the galvanometer. Okay, so let us discuss the first point. Between A and C, a battery of EMF E is connected. What is between A and C? This is the point A and this is the point C. So E has been connected. Okay, and between point B and D, a galvanometer is connected. Okay, between point B and D, galvanometer is connected. So now we are applying Kirchhoff's first law at junction B. What is the junction B? This is my junction B, no? Yes, no? So what is the current? Wait. So I1 will be equals to IG plus I. Yes. So one will be like when we are considering these 2 points. So one will be I1 is coming inside, Ig and I3 is going outside. So I1 will be equals to Ig plus I3. When we are considering this point, I2 will be coming in, Ig is also coming in, I4 is going out. So when we see here, I1 will be equals to I3 plus Ig, I2 plus Ig will be equals to I4. So equation 1 and equation 2. So now applying Kirchhoff's second law. So for which one? A, B, C, D. So in clockwise direction, when we are taking about clockwise direction, no, we should consider this sign also here. Okay. So for A, B, D, A. So in this direction, no, minus I2 R2, and this is going against, no, this is clockwise. Okay, if we come this side, no, if we come this side, like if we go this side, in the sense I2 R2 will come. If we come this side, in the sense R1 I1, that will be minus, and this one will be minus. Which one? Ig and G. And when I am going in this opposite direction, it will be plus I2 R2, right now? Yes, minus I1 R1 minus Ig G plus I2 R2 will be equals to 0. Similarly, when we talk about BCD, so BCD B, so BCD B in clockwise direction. So this one I3 R3 will be minus, and this I4 R4 will be plus, and this Ig G will be plus. I am going in this direction, no, this clockwise direction, right now. So I minus I3 R3, only one will be minus, remaining two will be positive, right now. So when no current passes through galvanometer, which means Ig will be equals to 0, the bridge is balanced, right. So I can say that I1 R1 will be equals to I2 R2, I3 R3 will be equals to I4 R4, right. So I1 will be equals to I3, I2 will be equals to I4. So substitute the values in 3 and 4. So what we will get? I1 R1 will be equals to I2 R2, R3 will be equals to I4 R4, right, no. So when I divide these two equations, right, what happens? This equation we have got from this previous Ig 0, no. So I1 I3, I2 I4, that one equal we got, and here also if we substitute, it is 0. So two equations we got, I1 R1, I2 R2, I3 R3, I4 R4. So when I1 and I3 are equal, no? I can cancel it out. I2 and I4 are equal, I can cancel it out. So remaining will be R1 by R2, R3 by R4. So now the bridge is balanced. So this is the condition for balancing Wheatstone bridge. Right? Yeah, you can take a note of this. Done. Okay. So the remaining question we will see in the next class. Okay, we will meet in the next class, guys. Bye bye. So any doubts? So these 3 questions will be exam, okay.